Hi guys, so today what we're going to be doing is we're going to be looking at what protects us from that solar radiation that you guys have been looking at. So remember, radiation is everything in the electromagnetic spectrum, whether good or bad, from radio waves all the way to gamma rays, including the visible light in the electromagnetic spectrum. These lines that look like a spider around the Earth, that is the magnetic core of the Earth. It's spinning and it's creating these magnetic field lines around the Earth, and that is keeping us safe from these solar wind particles. How does it do it? Well, it actually has the same charge as the solar particles of the sun, and so therefore it deflects it and keeps those harmful things from hitting our Earth. If we didn't have that, this would wipe our atmosphere off, scientists guess, around 5 minutes. That's how powerful these solar wind particles are. Now, again, solar wind particles are just charged particles. This graph is really cool because this graph actually allows us to see where this radiation is getting filtered out and stopped. Right here it says students in schoolyard at 0 kilometers. We have some kids at a schoolyard, yay. And then right above 5 we have 7. So 7 kilometers up, to get an idea of how much that is, that would be like Mount Everest. So that's the tallest mountain on the Earth's surface. At 10 kilometers we have a 747 flight. And to give you an idea how high that is. So that could go anywhere from above the clouds there. Here's a nice view here to 40 kilometers, so 40 kilometers above the Earth's surface. And we have a video of a high altitude skydiver. And of course, they're drinking Red Bull. What else would they be drinking? It looks like he has Red Bull in his hand, ready to dance because they have Red Bull. And what else do you do when you skydive? You drink your Red Bull and you dance. All right, then around 65 kilometers, we have it says rocket launch from balloon. You guys may have seen these before where they take a GoPro and they hook it up to a weather balloon and get right to the edge of space, which is really amazing. Here's a little video of it bursting. I think this is super cool. You can see all the shreds of that balloon as it goes down to Earth, but you can get an idea about how high that is from that video. Here we have the space shuttle. Space shuttle is at 200 kilometers. And to give you an idea, here it is floating about 200 kilometers above the Earth's surface. And just for kicks, but not on our graph, we're going to go above this 200 kilometer mark and go up to where the International Space Station stays, which is about 350 kilometers above Earth. The solar light comes in from outer space and is going down the graph this way. Now, some of this light is getting filtered out, and some of it's getting stopped before it reaches us, which is a good thing for some of these. Can you imagine if we get hit by X-rays and gamma rays? That would be very, very bad. So you have this sheet that says quiet sun data, and then you have this other one that says balloon/rocket mission. And what the idea of this sheet really is that you launch a balloon/rocket, and as it goes up in the atmosphere, it detects all the different types of radiation from the electromagnetic spectrum, radio waves, X-rays, gamma rays. And as it goes further up, it tells you how many units of that particular light that it detects. It's radio waves at 0 kilometers at Earth's level before it launches. It only detects 1 radio wave. And then at 5 kilometers, after that balloon goes up a little higher off the Earth's surface, it also detects 1 radio wave. And if I fast forward this video, you notice that, again, it's 1 unit of radio all the way up to the top. So what's really cool about radio waves is they don't get filtered out. Okay, so now let's look at UV radiation. So on, I think this is sheet B, at 0 kilometers, we look at UV light, we get 100 units. So go ahead and mark 100 units on your sheet, put a little dot. And at 5 kilometers, we're gonna do 900 units. At 10 kilometers, we do 1,230 units. So you can get an idea of what I want you to do. Then don't forget to draw a line and connect your dots. Of course, please do a much better job than I just did there. So what can we learn about this graph right here for UV? Going from 3,720 units to 100 at the Earth's surface is miraculous. Why is that miraculous? Well, it's miraculous because it doesn't get stopped all the way. If you look at the X-ray and gamma rays, it gets stopped. But the UV, there's something that filters it out where it doesn't filter all of it out. It gives us just what we need. More than that, it can be really bad. Less than that can be bad too, because you need that radiation for it to grow plants. We need it for vitamin D. We get too much UV radiation, it can be bad when getting cancer, things like that. So what I want you to do, just graph what you see on the quiet sun data table and put it on the 2 balloon, rocket, solar energy mission sheets. Next week, we're going to actually take that graph that you did, and we're going to mark where these radiations come from space, enter our atmosphere, and where they get stopped. And then we will also be doing this energy levels graphing sheet for when we have a solar flare and compare that to when we don't have a solar flare, how that affects the radiation hitting us. But we'll talk about that next week. So these two are attached, but you don't need to do them right now. You just need to do this one, sheet B, and sheet A. That's it. Please do it careful, do it neat. You can do it on Kami or print it out, take a picture, and then insert it into Google Classroom. That would work as well. Thank you guys for keep on with your work. I hope you guys are doing okay. Please email Emery or I if you have any questions about this assignment.